You're standing in your kitchen, floor's solid, walls aren't moving. You know exactly where the exits are, and if things got bad, you could Google earthquake safety tips in about 4 seconds. Now strip all of that away. No engineering codes, no seismologists, no warning apps buzzing 30 seconds before the shaking starts. Just you, standing on ground that suddenly decides it doesn't want to be solid anymore. Ancient humans had none of our tools, and yet entire civilizations survived, and even rebuilt, in some of the most seismically violent regions on Earth. So how did people with no instruments, no data, and no early warning systems figure out how to live through something that levels cities in seconds? The answer involves myth, engineering, and one genuinely brilliant piece of ancient guesswork. Let's start with what they thought was actually happening, because it's a lot weirder than plate tectonics. Ancient Japan blamed a giant catfish. Seriously, Namazu, a colossal catfish living underground, was believed to thrash around and shake the earth whenever a guardian god let his guard down. In ancient Greece, Poseidon wasn't just god of the sea, he was earthshaker, and temples were built with rituals specifically meant to keep him calm. So, no, they didn't understand subduction zones. But here's the thing worth noticing. Almost every culture in a high-risk earthquake zone developed some story to explain the shaking. That's not superstition for its own sake. That's pattern recognition, dressed up in mythology, because humans needed an explanation badly enough to invent one. But here's where it gets strange, because some of these myths accidentally encoded real survival knowledge. In Japan, catfish folklore didn't just explain earthquakes, it predicted them. Coastal communities noticed something long before modern science confirmed it. Unusual fish behavior sometimes preceded seismic activity. Catfish becoming agitated, surfacing strangely, moving erratically. Folklore attributed it to Namazu stirring. Modern researchers have studied potential links between animal behavior and pre-seismic environmental changes, though the science remains genuinely unsettled and debated even today. Here's the twist. Whether or not the catfish were predicting anything scientifically, the belief itself functioned as a warning system. People paid attention. Attention saves lives. A myth that makes you watch the water is a myth that occasionally gets you out the door in time. Which raises the real question, because noticing a quake is one thing. Surviving the building falling on you is another. Now here's the part nobody talks about. Some ancient societies were building earthquake-resistant structures thousands of years before earthquake-resistant was a phrase anyone used. Take the Inca. Machu Picchu sits in one of the most seismically active regions on the planet, in the Andes, and it's still standing 500 years later. The secret wasn't luck. Inca stonemasons cut stones to fit together without mortar in interlocking irregular patterns. When the ground shook, the stones could shift slightly, absorb the energy, and then settle back into place. Instead of cracking apart like a rigidly mortared wall, would engineers today call this kind of behavior seismic isolation? The Inca were doing it with hand tools and no written language for their engineering notes. Halfway across the world, the Japanese developed the five-story pagoda, a structure that has survived major earthquakes for over 1,000 years. Its secret is a central wooden pillar called the shinbashira, which isn't rigidly attached to the rest of the structure. During shaking, each floor can sway slightly independently, out of sync with the ones above and below it, dissipating the seismic energy instead of transferring it straight up into a catastrophic collapse. Modern skyscrapers use a strikingly similar concept called a tuned mass damper, a giant version of the exact same idea, just with modern materials and price tags in the hundreds of millions of dollars. So next time someone acts amazed that Taipei 101 has a giant swinging steel ball to survive earthquakes, just remember, a wooden pagoda figured out the concept 1,000 years earlier, with zero funding rounds involved. But wait, if ancient builders had this figured out, why did earthquakes still kill so many people throughout history? But here's the counterexample. Because engineering only helps if you actually use it. The 1755 Lisbon earthquake killed an estimated 30,000 to 50,000 people, and much of that death toll came not from the shaking itself, but from the tsunami and fires that followed, plus the simple fact that most ordinary housing wasn't built with any seismic consideration at all. Temples and palaces might get the interlocking stone or the flexible pillar. A regular family's home usually didn't. This is the uncomfortable truth. Ancient earthquake survival wasn't evenly distributed. It clustered around wealth, status, and sacred architecture. The catfish myth might warn everyone, but the seismic engineering mostly protected the people who could afford it. Some things, it turns out, have not changed nearly as much as we'd like to think. Which brings us to the part of this that isn't about walls or stones at all. It's about what happened between people, in the seconds after the ground stopped moving. Because here's the part that ties everything together. Survival was never just architecture. It was community. After a major quake, ancient communities from the Andes to the Mediterranean to Japan relied on the same core behaviors: shared labor to clear rubble, shared food when stores were destroyed, shared shelter when homes weren't safe to re enter. Disaster response wasn't a government agency, it was your neighbors immediately, because there was no one else coming. A wall built without mortar bends instead of breaking. A pillar built without rigid joint sways instead of shattering. A community built without hesitation rebuilds instead of scattering. Every structure that survived the shaking survived because something inside it was designed to move, not resist. And the people were no different. That flexibility, in stone, in wood, in each other, is the actual thread running through every earthquake surviving culture in history, not strength. So what about the places that never developed any of this? The exceptions? Not every ancient culture in an earthquake zone developed advanced seismic architecture. Some regions simply rebuilt the same vulnerable structures after every disaster, generation after generation, because resources, politics, or plain lack of transmitted knowledge got in the way. Survival wisdom isn't automatic. It has to be noticed, remembered, and passed down. And plenty of it was lost, rediscovered, then lost again over centuries. The Inca techniques, for instance, were largely ignored by Spanish colonial builders, who built more rigid European-style structures on top of the old foundations. Structures that unsurprisingly fared worse in the next major quake. So back to you, standing in that solid, stable kitchen. You've got seismic building codes, early warning apps, engineers who've spent careers on this exact problem. And still, somewhere underneath all that modern confidence, the same basic truth ancient builders figured out with hand tools and guesswork is the one holding your building up right now. Rigid things break, things built to move, survive. Maybe that catfish myth wasn't so foolish after all. Maybe it was just an early, imperfect attempt at the same thing we're still doing now, trying to notice the shaking before it notices us. The ground was never solid. We just learned to bend instead of break.